In this question, we want to determine the real solutions to the system of nonlinear equations. The system we're looking at is x plus y equals 4 and y equals x squared minus 8. When I start problems like this, the first thing I want to do is think about a visual representation of these equations. This is going to give me an idea of how many solutions I might have. So the first equation is a linear equation because we have the first power on these variables, and that means the graph is going to be a straight line. The second equation is a quadratic because of the squared on the x and not on the y. And the graph of a quadratic is a parabola. So I want to think about drawing a parabola and a line in the same plane, and this is one way we could draw it, in which there would be two intersection points and the possibility of two solutions. And we could also draw the line so that it just touches in a single point. We call that tangent to the curve. In that case, there's only one intersection point and one solution to that system. And it's also possible to draw the parabola and the line so that they don't touch each other. And that means there are no intersection points and no solutions to the system of equations. So we're looking at the possibility of having two solutions, one solution, or no solution. Now, getting back to our techniques for solving this, we have two methods that we typically use, and that is substitution and elimination. With the substitution method, the first step is to isolate one of the variables or solve for one of the variables. In the system that we're given, y is solved for, and so the first step of the substitution method is done for us. With the elimination method, we want to line up all of our like terms, having the x's lined up, the y's lined up, most importantly the equal sign, and then also our constants lined up. Eventually you'll add the equations together, and that's why you want all those like terms lined up. And you can see with this system that the way that it was given to us doesn't have the like terms lined up. So when I'm thinking about my choices of which method I want to use, because some of the work is already done for me, I would choose to go with the substitution method, although there's nothing wrong with going the route of using the elimination method. So I'm going to solve this with substitution. So the first step was already done for us. The equation is solved for y, and I want to substitute that into the other equation for y, and that's because this equals y. So when I make that substitution, I'll have x plus x squared minus 8 equals 4. This gives me a quadratic equation. Let me rearrange the terms. That's x squared plus x minus 8 equals 4. I'll move all those terms to the same side and solve this quadratic by factoring. So I'm factoring the expression x squared plus x minus 12. X times x is x squared, and I need to find two numbers that multiply to be negative 12 and add to be positive 1. I'm going to use 4 and 3 with a plus on the 4 and a minus on the 3. And then I'll use the zero product property and set each one of these factors equal to 0. That gives me solutions of x equals negative 4 and x equals positive 3. Now those are solutions to the equation that we have here, not solutions to the overall system. Solutions to the system should be ordered pairs. So we have the x-coordinate of one solution and the x-coordinate of another solution. We still need to find the y-coordinate. So I'm going to use this equation here, which has y solved for, y equals x squared minus 8, and with an x value of -4, I'm using this x value here, I can see that y would equal -4 squared minus 8. That's 16 minus 8, which is 8. So now I have one of my solutions, which is -4, 8. Let's find the other one. So now we'll use x equals 3. For x equals 3, y equals 3 squared minus 8, which is 9 minus 8, and that's 1. So the other solution would be 3, 1. So these are the solutions to my system of nonlinear equations. You can also check by substituting these ordered pairs into the original system. So let me clean this up. So let's check the ordered pair, -4, -8. I don't know why I wrote negative there. That should be +8. Sorry about that. So that's a +8. So in the first equation, x plus y equals 4, -4 plus 8 equals 4, and I get 4 equals 4, and that's a true statement. In the second equation, we have y equals x squared minus 8. That's 8 minus, 8 equals -4 squared minus 8. 16 minus 8 is 8. So that's another true statement. So that verifies that that ordered pair, -4, 8, is a solution to the system because it makes all of the equations in the system true. Now we can check the other ordered pair, 3, 1. For the first equation, x plus y equals 4. 3 plus 1 equals 4, and that's a true statement. For the second equation, y equals x squared minus 8, we would have 1 equals 3 squared minus 8. 1 equals 9 minus 8. 9 minus 8 is 1, and that's another true statement. So we've verified that both of these ordered pairs are solutions to the system of nonlinear equations. We want to determine the real solutions to the system of nonlinear equations. This system is x squared plus y squared equals 4, x squared plus y plus 1 squared equals 9. Now before we get started on solving, I want to have a visual representation, and I can tell by the format of this equation that they are both circles. The equation of a circle is x minus h squared plus y minus k squared equals r squared, where the ordered pair hk is the center and r is the radius. Both equations follow that format. So we have a circle which has a center of 0, 0 and a radius of 2. And then we have another circle, and this one has a center of 0, -1 with a radius of 3. So if we sketch two circles, we can get an idea of what the solution would be. These circles are pretty easy to draw. Normally I would just draw a sketch, but a circle centered at 0, 0 with radius 2, and a circle centered at 0, -1 with radius 3. So I plot the center at 0, -1, and I'm going to go 3 away from that, down, 3 to the right, 3 up, 3 to the left, and you get this circle here. I probably didn't do the best job of drawing that circle. It looks like to me that they're going to intersect in one point right here, which is the ordered pair 0, 2. But if we draw some other circles, it's possible for the circles to intersect in 2 points as well. And it's also possible for them to intersect in no points. So we could have no solution, 2 solutions, or 1 solution. So I'm guessing that this is the solution, but we're going to solve it using algebraic techniques. And that's with either substitution or elimination. So let's try elimination this time. I'm choosing elimination because as I look at this, my x squareds are lined up, even though it's kind of off stacking there a little bit. My y terms are lined up. Most importantly, the equal sign is lined up. And then I also have my constants lined up. So this problem is really set up for the elimination to work pretty easily. So what we can do, once we get everything lined up, we want to make sure that when we add the equations together, one of the variables is going to eliminate. In order for a variable to eliminate, you need to have like terms. And we have like terms with the x's. With the y's, we do have like terms, but because we would have to multiply this out, you would have one term that has a y squared and another term that has a y, and so you won't be able to eliminate the y's completely. So we have to eliminate the x's. These x's already have the same coefficient. Both of them have a coefficient of 1. When we add these equations together, we need the variable to eliminate, and that means we need to have one with a positive 1 and one with a negative 1. So I'm going to multiply by a negative onto the left and right side of the second equation. That's going to give me a new system of x squared plus y squared equals 4, negative x squared minus y plus 1 squared equals -9. Now when we add the equations together, the x's will eliminate. The y's will write out as y squared minus y plus 1 squared, and 4 minus 9 is -5. So we've successfully eliminated one of the variables, that variable being x, and now we need to solve the remaining equation. So I need to multiply out the y plus 1 squared, that's y plus 1 times y plus 1 equals -5. When we multiply out y plus 1 times y plus 1, we would have y squared plus y plus y plus 1 equals -5. I have y squared minus y squared minus, that's a plus 2y plus 1 equals -5. Negative to get y squared minus y squared minus 2y minus 1 equals negative 5. The y squareds cancel each other out, leaving me with negative 2y minus 1 equals negative 5. So now that the y squareds are gone, this is a linear equation. And to solve a linear equation, we try to get the variable by itself on one side. I'm going to add 1 to both sides to get negative 2y equals negative 4. I'll divide both sides by negative 2 to isolate that y, and that leaves me with a positive 2. So remember that solutions to these systems of equations are going to be ordered pairs. And we've already got the y-coordinate being 2. We want to find the x-coordinate. So I'll use that first equation. That first equation is x squared plus y squared equals 4. And let's substitute that y of 2 into the equation. That's x squared plus 2 squared equals 4. X squared plus 4 equals 4. And I subtract 4 from each side. I have x squared equals 0. And when we square root both sides, we'll get the solution of x equals 0. So the solution to this system is the ordered pair 0, 2. Thank you for checking out my videos. Have a great day.